Let's see what it looks like. Just give me a standard graph. Okay. Don't worry about the max and the mins. Just kind of get the look of the graph. We want to see where it's crossing this x-axis. It's going like this, it's coming down, it's turning and going up. Okay, don't worry about the max and the mins this time. All we're going to concentrate on are your zeros. Now, I can tell we have 3 roots. I can see it cross the x-axis 3 times. I need to find those roots algebraically. If I try to factor this polynomial, I can't factor this polynomial. There's not an x where the 6 is, not an x squared or an x. I can't factor out an x and then have a quadratic. So instead, I'm going to find the roots in my calculator. How do I find the roots or the zeros when I look at my table? How do I know what is a zero or a root of this function? Good. When it's on the y, I'm going to look for any y's of 0 and see if you can see 3 of them. Tell me as many of them as you can find. You didn't see any?
1.
Just 1?
Okay, 2.
You should find all 3.
Negative 3, 1.
Negative 3.
1 and 2.
1 and 2. Okay, so we can find these algebraically, graphically. Now, to find them out algebraically, we need a starting point. We need to find out if we can get this breakdown 1, get down to a quadratic, and then a quadratic we can factor. Whether we have to factor by factors, factor by quadratic, or complete the square, as long as we can get to a quadratic, we can factor that. So pick one of these. Pick one root to start with. 1, 0. 2. Okay, Manasia said first. So we'll pick a 2. We're going to divide out by a 2. Okay, so now pull out your coefficients. 1, 0. So let's test. 3, 2, 1, 0. Good. Let's divide out. Before we start, since this is a 0, what should this last guy be? 0. Our remainder theorem says if in fact it's a factor, I will get a 0 remainder because that's the 0 for the y when it crosses the x-axis. So sorry, this should be a 1. I'm talking and writing at the same time. So let's start our multiplying. 2 times 1, 2. Add down. 2 times 2, 4. Add down. 2 times negative 3, negative 6. Ah, and yes, that's a 0. Now, we can do one of 2 things. Since you have the rest of your zeros, we can keep dividing. We proved this one, right? Now we're down to a quadratic. We can come down here. We took away one of these. So this is my x squared plus 2x minus 3. This is my other factor. I can set this equal to 0, and I can factor this. X plus 3, x minus 1. And I can set them equal to 0, and I can find my other 2 roots. So altogether, my x's are, we found 2, we found the negative 3, we found the 1. If you want to put them in order, even better. So once you get down to a quadratic, either you're going to be able to find the factors or complete the square or use your quadratic to find the other 2. But you have to be able to get down to a quadratic. So if your highest exponent was a 4, we would take 1 out, synthetic division. God bless you. We would have to take another 1 out, synthetic division, so that we can get down to the quadratic. Now, because we were able to see all of them, you could have just continued this. Here was my line. Here was my last ones, right? You could have then divided by, because this is the algebraic solution. I can't factor these, so I'm synthetically dividing. I could now divide by a different one. I'll pick 1. I bring this down, I divide. 1 times 1, 1. I add down. 3, I come down. Oh, yes, and that should have been a 0, right? So now, I took 2 away. I was an x cubed. I went to an x squared. This is now an x. There's my last factor. Set it equal to 0, and there's my last 0. This is finding your roots algebraically. Remember, we always found our intercepts finding y equals 0, x equals 0, and we can't put y equals 0 and factor this polynomial. But we can search for a root and then divide it out and either factor or keep dividing. We can find your y-intercept still. We know your y-intercept, cover these. Your y-intercept is 6 when x is 0. And we can know where it crosses over here at the y-intercept. But the x-intercept, we cannot find by factoring because this is a polynomial. The highest exponent is greater than 2. So we have a little trouble finding it. So we'll look in your table, we'll find one root, we'll synthetically divide till we get down to an x squared. If you like and you found all 3 roots, you just have to make sure, show me synthetically, divide by another one, and that last one is left over. So either this way or this way. Okay? Are we kind of getting this? Kind of seeing it? Okay, we're pulling everything that you've been doing together. You've been doing x and y intercepts, and we're still doing them. You did synthetic division. So we needed your synthetic division so that we could divide out by these zeros to find the rest of them. Okay, let's try another one. Okay, how many zeros should this guy have? 3 zeros. How many turns? 2 turns. How many inflections? 1 inflection. Good. Now, can I factor this guy? Can I set y equal to 0 and factor this? No, even if I group, it won't work. So, I go to my graph. I need to find myself one real 0 so that I can divide it out and then be left with a quadratic. Can you find 2? If you find 2, we're good with 2. So let's have you put it in your calc.
Not 2, actually 2. Yeah, 2.
What? Say that again?
2 is the actual 0.
Oh, 2 is the 0. Oh, okay. I'm sorry. I thought you said 2, 0. Okay. Sorry. You're way ahead of me on this one. Okay, so let's graph this. Don't worry about adjusting your max and your mins. I don't care where they go. I should see 3 of these guys. I know that it comes from the left down to the right up. So I know it went like this somewhere, crossed over, came like this, came down, came back up again. All I care about right now are these guys. Don't even adjust your window. You know the left comes from down, so you know which way it's starting. Okay? So we go to the table like Lamisa said, and we find a 0. And you only can find one of these, right?
Yeah.
Did you find more? You found a negative one? No, you can only find one, right?
Yeah.
So, that means if I can't see them, either the other ones are fractions or they're irrational, and I can't see them. But I have 1. So I can start dividing by one of these. I'll divide by, well, I can only divide by the 2. So pull out your coefficients. 10, negative 15, negative 16, 12. 3, 2, 1, 0. What does this last space have to be here? 0, because this, in fact, is a root. If it doesn't come out to 0, we did something wrong. So bring down your first number, and we multiply from the left to the right. 2 times 10, 20. Negative 15 plus 20 is what? 5. Good. 2 times 5? 10. Negative 16 plus 10?
Negative 6.
2 times negative 6?
12.
Ah, yes, we did get a 0. Now, we started at x3. Say it real simple. I took away 1. I'm at x2. 10x squared plus 5x minus 6. This is my other root for this. This is my other factor for this. A quadratic, I should be able to set this equal to 0 and either factor this, use my quadratic equation, or complete the square. Okay? One of those I should be able to do. Let's see if it's factorable. 10 times negative 6 is negative 60. Do I have any factors of negative 60 that add up to 5? No. No? Okay, so no. So we have another choice. We have two choices. We can complete the square, or we can use your quadratic formula. Yeah, I agree with Asia on this one, because what happens with this is, if I complete the square, I have an odd, and I have 10 that I have to factor out. I have to factor this out. If it's a complete the square, and this is even and it's fun, easy, do complete the square. If it's a little bit involved, do your quadratic. And so A is 10, B is 5, C is negative 6. And yes, you have to know this formula. And no, I don't sing the song. I don't sing very well. It's a cute, catchy little tune, but I don't sing well. All right, so let's plug them in. So I get negative 5 plus or minus 5 squared is 25 minus 4 times 10 times negative 6 all over 2 times 10. And we said there was a reason we couldn't see this in our there was a reason we couldn't see this in our calculator on our screen. Probably we're irrational. So now, negative 5 plus or minus, put this little piece into your calculator, but without the radical sign. Don't put the radical sign under it. So 65, did you get underneath your radical sign?
Mm-hmm.
Try it again. 25 minus 4 times 10 times negative 6. 240 and 25 should give you 265. Can we reduce that radical at all? Do we have a perfect square? Probably none that we know of, right? None that we know of. So we leave it like that. If you can reduce it, you have to. If you can factor this and reduce your fraction, you have to. But there's nothing in front of this radical. So you cannot cross out the 5 and the 20.
We want them to be like that?
Because these are two terms. So it's like if you did this. Can you cross out this too? No. So you can't cross this out. You can only do it if there was a 5 here. I could factor out a 5. I can take out a factor, not a term. Yes, Carla?
What's the number in the radical?
265. So this is as reduced as you can go, unless you separated it, but you don't have to separate it. So this gives us 2 roots. So now we have 3. We found the 2 in our calculator, we divided it out, and we found these other 2. And you can leave it just like this. If it's reducible at all, you have to reduce it. Okay? And let me show you something. Let me show you a little easy way to check on your calculator. Check your root. Let's go to pull up, bring up your I don't have a calculator to bring up. Forget pair. So you know how we just did your quadratic formula? We came out with the negative 5 plus or minus the blah, 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 blah. This, and didn't we get a plus or minus? What should the other factor be for this?
2 plus radical 5.
Good, 2 plus radical 5. These are called your conjugate pairs. You absolutely know that to be a fact because they have to roll in pairs. Otherwise, we really can't find one of those in your calculator or by factoring. So they have to have come from either a complete square or a quadratic equation. So they have to come in a pair. Now, we can synthetically divide this out, and then we can synthetically divide by the next one. Or we're gonna do it a little bit differently. We're gonna take these two, and we're gonna find where the quadratic, where this came from. If I have two roots, it came from a quadratic. I probably did the quadratic formula, or I completed the square. So we're going to work our way backwards. So we're going to say we had two formulas that you learned in Algebra 2. The sum of the roots and the product of the roots. Do you remember these formulas? They would help you to get your quadratic back. They helped you get your quadratic back. So now, the nice part about this conjugate pair is, did you ever see a quadratic that has a radical in it? No. So when we add and multiply them, the radicals will take care of themselves. So this part you're going to do on your calculator. Watch. You're going to put this in your calculator. With parentheses, you're going to go like this. Plus 2 plus radical 5. Just put that in your calculator and tell me what the sum is. The sum is 4. Everybody get 4? Okay, now do second enter. Pull that operation back down and change this plus to a multiply. Second enter, pull it down, slide over the thing to the plus sign, hit multiply. Multiply these two. Tell me what your product is. -1. Everybody good with that? We just did the sum and the product in your calculator because you never see a quadratic with that radical in here. It takes care of itself. So, we're going to go back to our formulas. We're going to set my sum equal to -b over a and my product equal to c over a. Now, what we do is, because we have two variables in one equation, we can only solve for one variable in one equation, we let a equal 1. Remember doing this? Now, I'm going to circle this. This is what's left. So if -b is equal to 4, what is b equal to? I got to solve for the positive b. So what is b equal to? Nope, -b is equal to 4. So -4, divide by a -1, right? So I circle this. A is gone. What is c equal to? C is just a plain old C. So c is equal to what? -1. It says it right there. C is equal to -1. So ax squared plus bx plus c. A is 1 because we made it 1. B is -4. C is -1. That's the quadratic that if I did the quadratic formula, I would find those two, that pair, that conjugate pair. If I completed the square, I would find that conjugate pair. So that's 2 of my roots already. How many more do I have to find? 1. So I'm going to take this guy and I'm going to divide by that quadratic. A will always be equal to 1 because that's what we're going to make it. So therefore, I'm going to do a double divide. I take the last two terms and I take them out the opposite way.
Oh.
Remember the double divide?
So you have to put the new quadratic in the denominator.
Yes, because now that takes care of 2 of our pairs. If we divide that out, we should be left with the last factor, shouldn't we? That's 2 at once we take care of. So now, pull out your coefficients. 1, -1, negative 13, negative 3. We're going to do this as a double divide. We're going to bring down the 1. We always multiply from the left to the right. Start at the left here. 4 times 1 to the right, 4. 1 times 1 to the right of that, 1. Stop and add down this column. What do I get? 3. Multiply again. 4 times 3 to the right, 12. 1 times 3 to the right, 3. Now, weren't these two factors? So shouldn't I get a remainder of zeros? And didn't I do two factors at once? So shouldn't these both guys be 0? When I add them down, aren't they both 0? So I'm an x3 over an x2. This is a x plus 3. Set it equal to 0. And there's my last root. So my roots are negative 3 and 2 plus or minus radical 5. This is the hardest one you'll see. Yes. No, not really, because the problem is this.